In part 1 of our lesson on curve sketching, you will learn about asymptotes. Let's do a quick review of vertical asymptotes and horizontal asymptotes. For vertical asymptotes, we know the line x equals c is a vertical asymptote if either the limit as x approaches c from the left is infinite or the limit as x approaches c from the right is infinite. So remember that when you're proving a vertical asymptote, you have to look at the one-sided limits, and that will also give us information about the behavior of the graph. For horizontal asymptotes, the line y equals L is a horizontal asymptote if either the limit as x approaches positive infinity equals L, which is some real number, or the limit as x approaches negative infinity of f of x is equal to L. There's a third type of asymptote called a slant asymptote, which we will abbreviate SA, and that occurs in a rational function when both of the following conditions occur. So you have to have both conditions. First, the degree of the numerator is exactly 1 higher than the degree of the denominator. So it has to be exactly 1 more. And then if that's true, you go on to step 2, which is that a remainder exists after performing the polynomial long division. So let's see how this is going to work using this example where we have to determine all the asymptotes for this given function. Now remember, for vertical asymptotes, we are going to look at the x values where the denominator would be 0, and if we have those, then we will do one-sided limits. For this function, x equals -3 is the x value of interest, so let's do a one-sided limit. We can go limit as x approaches -3, and we could either say from the right or from the left. I guess we'll do from the right. We have 2x squared plus 10x plus 15 divided by x plus 3. Now the first thing that you always try is direct substitution. So if we put -3 in for the x, this will turn into 9 times 2, which is 18. Then we have 10 times -3, which would be -30. And then we have to add 15. In the denominator, of course, we have 0, but because this is a one-sided limit, we have to decide whether this is 0 plus or 0 minus. Think of a number line. Here's -3, and if we are coming in from the right, then we are coming in through numbers slightly bigger than -3, so you think -2.999. Now this isn't actually what gets plugged in, you just use this value to think your way through. So if we were to put a -2.999 and add 3, that's going to be a tiny positive number. So now the numerator simplifies to 3. The denominator is a 0 plus. This goes to positive infinity. Therefore, there's a vertical asymptote at x equals -3. Now for horizontal asymptotes, we look for the degree of the numerator to be less than or equal to the degree of the denominator. And if that happens, then we do the limits at positive infinity and negative infinity. However, in this case, the degree of the numerator is bigger than the degree of the denominator. So we know right off the bat that there are none because the degree of the numerator is greater than the degree of the denominator. That makes a horizontal asymptote impossible. Then we can check for slant asymptotes. And remember, the rule for slant asymptotes was that they can occur if the degree of the numerator is exactly one higher than the degree of the denominator. And that is the case we have here because the degree of the numerator is 2 and the degree of the denominator is 1. So it is possible. We don't know that there is one, we just know it's possible because the degree of the numerator is exactly 1 more than the degree of the denominator. Now when that happens, we have to do polynomial long division, everyone's favorite. So now we have to take x plus 3, which is the denominator, and divide that into the numerator of 2x squared plus 10x plus 15. If we do this division, we know that x will go into 2x squared. We'll have to multiply by 2x. 2x times x is 2x squared. 2x times 3 gives us a positive 6x. Now we have to subtract, and 2x squared minus 2x squared cancels out. That's why we picked the 2x. And 10x minus 6x is going to give us 4x. We bring down the plus 15. Now we want to cancel out this 4x, so we're going to add 4 up here and then do the multiplication. 4 times the quantity x plus 3 is going to be 4x plus 12, and then we have to subtract that. 4x minus 4x cancels out. 15 minus 12 is 3, and this is the remainder. And because there's a remainder, we can say, therefore, there is a slant asymptote at y equals this quotient up here, 2x plus 4. So remember, to check for a slant asymptote, it has a two-part hypothesis. First, you make sure the degree of the numerator is 1 higher than the degree of the denominator, which we did have. If you have that, then you do the polynomial long division and see if you get a remainder. So this function, we found we did have a remainder after the polynomial long division, so then we use the quotient in an equation for a line to get the slant asymptote. Now, Horizontal asymptotes and slant asymptotes cannot happen simultaneously, and that is because the conditions which must exist are mutually exclusive. So to get a horizontal asymptote, the degree of the numerator has to be less than or equal to the degree of the denominator, whereas the condition to get a slant asymptote is that the degree of the numerator must be greater than the degree of the denominator by 1. So it has to equal the degree of the denominator plus 1. These two things can't happen at the same time, so since these conditions are mutually exclusive, a slant asymptote and a horizontal asymptote cannot both occur at the same time. In this example, we have to determine all the asymptotes for the given f of x. Now, for vertical asymptotes, we know that we will look for the x values where the denominator would be 0. In this case, that would be -3. And then we do a one-sided limit. So let's do the limit as x approaches -3. We can either do from the right or from the left. I guess we'll do from the right. Now, we have the function here. If we were to plug -3 into the function, of course the denominator is 0, the numerator would become 18 here, plus 15 is 33, and then 11 times -3 is -33, so we can see we would have 0 over 0. So let's go ahead and factor this numerator. We know the only way to get 2x squared is going to be 2x times x, and to get 15 we could either do 5 times 3 or 15 times 1. Let's try 5 times 3, and checking that, we would get 6x plus 5x gives us our 11x. So that's the proper factoring. Then we have x plus 3 in the denominator, and of course we know in the limit we are allowed to cancel those terms, so this becomes limit as x approaches -3 from the right of 2x plus 5. If we plug in -3 for x and simplify, we are going to get -1. And since our one-sided limit is not infinite, that means there's no vertical asymptote. Now let's check for horizontal asymptotes. Now for that, we need the degree of the numerator to be less than or equal to the degree of the denominator. And because the degree of our numerator is greater than the degree of the denominator, we have to say none. And the reason we give is because the degree of the numerator is greater than the degree of the denominator. Lastly, we can check for slant asymptotes. And we do have the first condition, which is that the degree of the numerator must be 1 more than the degree of the denominator. So it's possible because degree of the numerator is 1 more than the degree of the denominator. Now we have to do the polynomial long division. So we've got x plus 3 being divided into 2x squared plus 11x plus 15. So we have to multiply 2x times the quantity x plus 3, and we will get 2x squared plus 6x. We have to subtract. These two cancel out, and 11x minus 6x is 5x. And we bring down the plus 15. We would multiply times 5. So 5 times the quantity x plus 3 is 5x plus 15. Now when we subtract that, we see that we have 0 for the remainder. And so because of that, no slant asymptote. So in this case, this f of x has no asymptotes at all. We have to determine all the asymptotes for this f of x, and we walk through. Vertical asymptotes will occur in the places where the denominator is 0, but 4x squared plus 3 is never going to equal 0, therefore no vertical asymptotes. For horizontal asymptotes, we need the degree of the numerator to be less than or equal to the degree of the denominator. In this case, the degree of the numerator is 1, and the degree of the denominator is the square root of x squared, which we know is absolute value of x, which is either negative x or x, whose degree is 1. So effectively, the degree of the denominator is 1, which is the same as the degree of the numerator. So because that condition is satisfied, we look at the limits at both positive infinity and negative infinity. So the limit as x goes to infinity, we have 12x in the numerator, and we have the square root of 4x squared plus 3 in the denominator. Now we want to multiply by 1, which means we're going to multiply both the top and the bottom by 1 over the square root of x squared. Now in the numerator here, we have a problem because the x is not under a radical, and this x squared is under a radical. So we are going to rewrite this. We know that the square root of x squared is absolute value of x, and in this case, because we are going to infinity in a positive direction, we know that x will be a positive number, therefore absolute value of x becomes x. And now it is this expression that we will use to multiply the numerator. So this becomes the limit as x goes to infinity of 12 over. Now in the denominator, it's easy because they are both under the radical, so the result will be under the radical, and we have 4x squared times 1 over x. Remember, they're both under the radical, so this becomes 4, and then 3 over x squared. Now we can perform the limit as x goes to infinity, and we know that 3 over x squared is going to go to 0. So now we've got 12 over the square root of 4, which is 12 over 2, which is 6. So therefore, we have a horizontal asymptote at y equals 6. Now we have to look at the limit as x approaches negative infinity of 12x over the square root of 4x squared plus 3. Once again, we will need to multiply by 1, and we will use 1 over square root of x squared over itself. Now in the denominator, this is an easy one to do. We've got our limit, x is going to negative infinity. Both this term and this term are under the radical, so 4x squared over x squared is 4 plus 3 over x squared. In the numerator, we need to get this x squared out from under the radical, so this becomes 1 over the absolute value of x. And this time, because we are going through negative numbers, that means that this is going to simplify to be 1 over negative x. And now that is what we will use to multiply times the numerator. So 12x times a negative 1 over x is negative 12. So this is equal to negative 12 over the square root of 4, which is negative 12 over 2, which is negative 6. So therefore, we also have a horizontal asymptote at y equals negative 6. So we had no vertical asymptote. We did end up with two different horizontal asymptotes. And the last thing that we have to check for is slant asymptotes. But we know for slant asymptotes, it's going to be none because we had horizontal asymptotes. And remember, they can't happen at the same time.